Hi, we're Team 17, and this is our video summary for the automated electropolish line project with Autocam Medical. Today we'll cover the problem we're solving, how we landed on our final concept, a breakdown of the system's subassemblies and workflow, and a quick summary. Electropolishing works by connecting parts to an anode and lowering them into an acid electrolyte. Current drives an oxidation reaction that dissolves high spots on the metal, eliminating them and leaving a smooth, passivated surface. A few key terms before we go further. The frame holds the screws and clips, the dovetail connects the frame to the EP tank, and the line refers to the acid tank followed by 3 rinse tanks. Right now, this is all done by hand. An operator loads screws into the frame, connects it to the tank, runs it through polishing, and each rinse step then unloads the finished parts before starting the next batch. Our goal is to automate this existing electropolish line at Autocam Medical's East Paris facility so parts can be processed safely and reliably with minimal human intervention. To validate the design, the final system will run a 10-hour equivalent shift, processing 4 jobs across the largest and smallest screw combinations. It needs to stay within spec with no major faults. Here is a look at our initial CAD design and layout. The system runs on 208-volt input, managed by an Allen Bradley PLC with a 24-volt supply, I/O link, and Ethernet IP tying all the components together. This is a picture of the initial panel layout. An Epson 6-axis robot arm, already on hand at Autocam, handles all the part movement, fitted with electric grippers that give real-time feedback on grip status. Parts are stored in peak trays that match Autocam's existing standard. Dowel legs on each tray index its position for precise, repeatable pickup by the robot. Tray tables lock each tray into place using dowel holes with a proximity sensor and fixture clamp confirming it's properly seated before a cycle begins. Our frame builds on the previous design, adding 8 more clip locations to polish more screws per cycle. Frame hangers hold and locate the frame during loading, with a proximity sensor confirming it's seated correctly. The cell is enclosed with aluminum T-slot framing and wire mesh, with 4 interlocked access doors for safe operator access, all mounted to the fixture table to keep the footprint small. The robot picks screws from the input tray, loads them into the frame, connects the frame to the tank for polishing and rinsing, then unloads the finished parts into the output tray, repeating automatically until the job is done. Up next, a few videos and pictures of the final design in action. This is a snippet of the loading sequence. The robot can be seen picking up individual parts and loading them into their respective clips. Our team designed the gripper fingers to hold onto the screw while leaving a gap in the middle which allows the fingers to not interfere with the clip. With this design, there is ideally no bending moment when the robot goes to insert the into the clip. This is a snippet of the unloading sequence. The robot can be seen picking individual parts off of the frame and transferring them to the output tray. This portion of the sequence presented us with the most difficult challenge, which was getting the fingers to pick up the parts vertically with repeatability. In this video, our group was testing a slightly different tray design, which is why there is only a portion of the tray visible. This video showcases a complete run-through of a batch sequence. The robot is seen taking a frame and transferring it to the electropolishing bay. While the first frame is being electropolished, the robot unloads the second frame, so there is no wasted time. After the robot unloads the second frame, it finishes transferring the first frame through the final rinse tanks. Finally, the robot places the electropolish frame on its rack, ready to be unloaded. Here is the overall layout of our new main control panel, which houses the PLC, power supplies, relays, and main power disconnect. Here is a sneak peek the operator's HMI. The operator will be able to control the entire cell from this interface, which includes inputting the recipe needed for the specific parts being electropolished, which can be seen here. Finally, here is a picture of the final robot cell. The HMI can be seen attached to the EP line on the left, and the finished cage is seen surrounding the robot. Team 17, thanks you for watching our video demonstration. Have a great day.